Throughout the age of dinosaurs, terrestrial, marine, and flying reptiles of various species and sizes spread across the planet. Many regions of Earth back then were vastly different from the landscapes we know today. However, even then, there were places that were far from ideal for life. Today, we want to tell you about how dinosaurs and their relatives adapted to living in deserts, swamps, highlands, and polar regions. You'll learn about the remarkable evolutionary mechanisms and discoveries made by scientists studying these extraordinary creatures of their time. Subscribe to our channel. Also, don't forget to like the videos you enjoy and leave your comments below them. These actions help promote and grow our channel. Your engagement will also allow other science enthusiasts from around the world to discover our content. In the distant Mesozoic era, our planet looked entirely different from what it is today. At the beginning of the dinosaur age, all continents were joined into a single subcontinent called Pangaea. By the end of this era, they were positioned almost as they are now. However, many landscapes resembled those inhabited by modern animals, though each had its own unique characteristics. Next, we'll explore the most common ecosystems and focus in detail on the inhabitants of the least hospitable environments. Vast areas of Pangaea were covered by grassy plains, though calling them that is a bit of a stretch, as true grass didn't exist yet. Its role was filled by low-growing ferns. Herds of various ceratopsians, hadrosaurs, and ornithopods roamed these plains, actively hunted by theropods like Tyrannosaurs. Many dinosaurs lived on the low-lying, frequently flooded plains of Europe during the Cretaceous period. These wetlands covered enormous territories. Constantly nourished by sediment flowing down from the mountains and hills, they were a paradise for herbivores. Herds of iguanodons, as well as polycanthuses and tiny hypsilophodons, wandered through them, feeding on various horsetails and ferns. One of the most unusual dinosaurs to inhabit swamps was Dinochaurus. This large ornithomimosaur lived in what is now Mongolia during the late Cretaceous. It reached lengths of 11 to 12 meters, 36 to 39 feet, stood over 4 meters, 13 feet tall, and weighed up to 5 to 7 tons. Its body structure suggests it wasn't a fast runner. However, what makes Dinochaurus stand out is not its speed, but the structure of its forelimbs. Not only was Dinochaurus the largest of the ornithomimosaurs, but it also had the longest forelimbs of any theropod, measuring over 2 meters, 6.5 feet, and ending in 3 very long claws. These were likely used not so much for defense, but for pulling down tree branches, from which the dinosaur would strip leaves with its beak. Dinochaurus wasn't strictly herbivorous, it also ate fish. In a swampy environment, such a diet was ideal. Thanks to the swampy soil in what is now the German city of Tübingen, scientists were able to discover and study a new dinosaur called Tübingosaurus. This dinosaur belongs to the Plateosaurids, a group similar to sauropods but not closely related, from the late Triassic period. Due to the poor preservation of previously found specimens, scientists struggled to describe this group in detail, but Tübingosaurus provided a scientific treasure. It appears to have drowned in a swamp, falling on its side. Half of its body, buried under a layer of mud, was spared from scavengers or predators. Lush coastal forests grew along the rivers and swamps of the dinosaur era. These provided shelter for a wide variety of animals. The most famous of these are the coastal forests of the Morrison Formation in the United States, where the first remains of Diplodocus and Allosaurus were discovered. Coastal forests were typically flooded only during river or swamp overflows. However, Some forested areas were permanently swampy. In these waterlogged groves, the first flowering plants appeared earlier than in other ecosystems. Huge herds of duck-billed dinosaurs grazed in these flooded thickets, attracting carnivorous dinosaurs of all sizes, from troodons to tyrannosaurs. Life thrived in the waterways themselves. Rivers and lakes were the domain of various aquatic reptiles, amphibians, and crocodilomorphs. But many dinosaurs also actively hunted underwater prey. The most striking example of this adaptation is Spinosaurus. Scientists now have little doubt that this giant theropod led a semi-aquatic or possibly fully aquatic lifestyle. Close relatives like Baryonyx, which lived in Europe, and Suchomimus from North Africa weren't far behind. All of them had crocodile-like snouts with long jaws and thin, sharp teeth, perfect for catching and holding fish or other aquatic prey. Dinosaurs also lived along the shores of seas or oceans, though these shores were not where they are today. For example, one migration route of herbivorous dinosaur herds in the United States ran along the coast of an inland sea that, during the Cretaceous, covered parts of what are now Colorado and New Mexico. Today, the nearest ocean coast is in California. Migrating dinosaurs might have preferred those areas far more. Surviving in a desert is tough for any living organism. Yet, both now and in the age of dinosaurs, some creatures thrived in such extreme conditions. While the Sahara was covered in lush jungles back then, the Gobi Desert in Central Asia was already a vast sea of sand. The desert's arid climate, with near-zero humidity, promotes the excellent preservation of organic remains, and layers of sand protect bones from being scattered by other animals. It was in the Gobi Desert that dinosaurs like Protoceratops, Oviraptor, and Velociraptor were found. One remarkable fossil shows a Velociraptor and a Protoceratops locked in combat. It's believed a sandstorm buried the two dinosaurs during their struggle. There's also a chance that both were already dead, having inflicted fatal wounds on each other by the time they were buried under the sand. Let's explore how these dinosaurs survived the harsh conditions of the Mesozoic desert. Protoceratops was relatively primitive compared to its North American relatives, like Triceratops. Initially, it was thought to be an ancestor of other ceratopsians, hence its name. It lacked prominent horns, sporting only a robust, leathery frill. Scientists believe one function of this frill was to dissipate excess heat, a critical adaptation for desert survival. Oviraptors and velociraptors were small, carnivorous theropods, weighing no more than 20 kilograms, 44 pounds, and covered in feathers, suggesting they were likely warm-blooded. Feathers provided modern birds with effective thermoregulation, and they likely served the same purpose for these dinosaurs. It's probable that these dinosaurs weren't exclusively desert dwellers. Most likely, they inhabited semi-deserts and sparse woodlands. However, a small theropod called Shuvuia was likely a true desert resident. Its remains were also found in the Gobi Desert. Scientists were astonished by its striking resemblance to birds. Shuvuia means bird in Mongolian. This tiny alvarezar weighed only 1 to 2 kilograms, 2 to 4 pounds, stood up to 25 centimeters, 10 inches tall, and had a body length of up to 70 centimeters, 28 inches. Shuvuia is thought to have had excellent hearing and vision and led a primarily nocturnal lifestyle. Analysis of the eyes of nearby velociraptors suggests they were crepuscular, active at dawn and dusk, so Shuvuia likely occupied a niche similar to modern owls. Some of the most comfortable ecosystems for dinosaurs were likely the shores of shallow seas and lagoons formed by reef chains. Such places are teeming with diverse life even today. Lagoons inhabited by various petrosaurs as well as Compsognathus and Archaeopteryx existed, for example, in what is now Europe. The remains of these animals are well preserved in the muddy layers at the bottom, or along the shores of these water bodies. A prime example is the lagoon discovered in Zonhofen, Germany. Little is known about dinosaurs that lived in mountainous regions. An example of a highland dinosaur is Andysaurus, a sauropod whose remains were found in the Andes of South America. However, it seemed these dinosaurs settled along riverbanks and swamps. Andysaurus was a relatively small, herd-living sauropod, reaching 15 to 20 meters, 49 to 66 feet in length, and weighing no more than 7 tons. Populations of animals living in isolated island environments often involve distinct traits. These changes frequently manifest as reduced body size and overall simplification of organisms. Examples include the dwarf mammoths of Wrangel Island and the hobbits of Flores Island, which we've mentioned in previous videos. During the dinosaur era, islands also hosted unique species. About 100 million years ago, what is now Romania was home to Hattig Island. Dwarf titanosaurs called Magyarosaurus and primitive ornithopods called Telmatosaurus lived here. The remains of a giant petrosaur, Hatzegopteryx, were also found, though islands likely served as temporary stopovers during its seasonal migrations. By the late Cretaceous, the climate in polar regions, while not as harsh as today, was still challenging. Dinosaurs living in the North and South Poles had to adapt to these tough conditions. Alaska is a well-studied and revealing location in this regard. Numerous dinosaur species have been found there. Although the peninsula was already within the Arctic Circle at the time, the climate was much milder than it is today. As a result, Alaska was more densely populated than it is now. These animals had to survive polar nights and sub-zero temperatures. Among the most notable dinosaurs that lived in Alaska are Pachyrhinosaurus, Edmontosaurus, Nanoxaurus, Troodon, Saurornitholestes. In addition to dinosaurs, the polar forests of the late Cretaceous, composed of primitive coniferous trees, were home to early mammals. A typical creature of this region was Unuacomes, a small animal distantly related to modern opossums. How did these ancient polar inhabitants survive polar nights and cold winters? In the modern animal world, several mechanisms allowed species to cope with these challenges. Some enter hibernation, slowing their metabolism and conserving stored fat. This is not uncommon among reptiles, which dinosaurs essentially were. However, scientists have yet to find evidence of a dinosaur hibernating in a cozy den. Many modern animals in polar regions migrate to warmer, food-rich areas during the cold season, like caribou. However, some populations remain in extreme conditions year-round. It's been proven that Edmontosaurus in Alaska were sedentary herbivores. Scientists compared the bone structure of Alaskan Edmontosaurus with those from other regions, as these dinosaurs were widespread as far south as modern-day Colorado. Animal bones have a similar structure to tree rings, with thinnest layers of calcium forming during unfavorable seasons. Alaskan Edmontosaurus bones show distinct banding. Additionally, it was found that by the onset of the polar night, Edmontosaurus hatchlings were still too small to endure long migrations south. In contrast, migrating caribou calves are much closer to adulthood when migrations begin. The dominant predator in Cretaceous Alaska was Nanoxaurus, sometimes called a dwarf tyrannosaur. Nanook means polar bear in local dialect. Reconstructions often depict this theropod as covered in short, white down. However, few Nanooksaurus remains have ever been found. It was a classic bipedal carnivorous dinosaur, up to 7 meters, 23 feet long, and weighing about 2 tons. Initially, researchers thought its small size was an adaptation to the harsh climate, but later reconstructions showed that adult Nanooksaurus was comparable in size to other moderately sized tyrannosaurids. The southern polar regions were also densely populated during the dinosaur era. At that time, Antarctica's climate was closer to temperate, and the continent was covered in vast forests. Finding dinosaur remains under meters of ice is nearly impossible today, but nature occasionally surprises scientists with remarkable discoveries. During the summer thaw of 1990 to 1991, the skull and several bones of an Arctic theropod, later named Cryolophosaurus, meaning frozen crested lizard, were found. This predator, up to 8 to 9 meters, 26 to 30 feet long, and weighing about 900 kilograms, 2,000 pounds, had an ornate crest on its skull, likely used to attract mates. In the future, more dinosaurs that lived in Antarctica may be discovered. For now, with the continent buried under ice, we can learn about polar region inhabitants by studying fossils found in Australia. During the dinosaur era, Australia was much closer to the South Pole than it is today, experiencing polar nights and cold temperatures. Examples of adaptations to these harsh conditions include Leolinosaura, with its very large eyes, and Minmi, a small, possibly cold-blooded ankylosaur. Nature on our planet is designed so that living organisms strive to colonize every corner, from the depths of the Mariana Trench to the summit of Everest. Dinosaurs were no exception. As science advances and new data emerges, we will undoubtedly learn about more extraordinary Mesozoic species that lived in seemingly impossible conditions. This ability to adapt to environmental changes allowed all modern species, including humans, to emerge. Today, humans live in mountains, deserts, and even beyond the Arctic Circle. In the future, we may need to adapt to long journeys through the depths of space and the unfamiliar conditions of other planets.
When you look at the incredible number of new fossil species discovered over the past few years, including many new dinosaurs, you can't help but remember that old joke. They all look the same. Scientists just put the bones together differently. But in truth, during the 185 million years that dinosaurs ruled our planet, evolution created an astonishing variety of shapes, sizes, and sometimes truly bizarre creatures. Today, we invite you to dive into the world of the most unusual dinosaurs ever discovered. We'll explore why they looked the way they did, and how those strange features may have helped them survive. By subscribing to our channel, you'll always be the first to discover new episodes. And don't forget, your likes and comments under the videos help our Age of Dinosaurs channel grow and reach even more curious minds. Incisivosaurus, the rodent dinosaur from ancient China. In 2002, in the Liaoning province of China, paleontologists unearthed the skull of a most unusual dinosaur, one that roamed this region between 125 and 130 million years ago. What made this skull truly unique were the dinosaur's enormous front teeth, very much like those of modern-day rodents. And just like in rodents, these long front teeth showed clear signs of wear and tear. This led scientists to believe that Incisivosaurus fed mainly on tough plants and pine cones. although it's possible that it was actually an omnivore. So far, the skull is the only bone we've found from this curious creature, but based on its features, scientists placed it among the oviraptors, and it's actually one of the oldest members of this group. Based on the skull and comparisons with other oviraptors, we can imagine how Incisivosaurus might have looked, about the size of a modern chicken, no more than 1 meter long, and weighing just 2 kilograms. Considering that we know for sure it had feathers, the resemblance to a chicken becomes even more striking. Kentrosaurus, the little stegosaur covered in spikes. These fascinating dinosaurs lived in what is now Tanzania. During the late Jurassic period, about 150 to 155 million years ago. Between 1909 and 1910, a team of German scientists spent 4 seasons collecting more than 1,200 bones from these creatures. From that treasure trove, they managed to reconstruct 2 full skeletons, both now housed in museums in Germany. Unfortunately, some of the bones were lost during World War II. Kentrosaurus was officially described in 1915 by the paleontologist Edwin Hennig. Its name means lizard with spikes, and so far, only one species of Kentrosaurus has been identified, one that lived in East Africa. In 1914, American researcher Charles Gilmore suggested that a similar stegosaur discovered in the US might also be a Kentrosaurus, but that idea didn't gain traction among scientists. By stegosaur standards, Kentrosaurus was actually quite small. It grew to about 4.5 to 5.5 meters long, stood only 1.5 meters tall, and weighed between 1 to 1.5 tons. Like other stegosaurs, Kentrosaurus had a tiny brain, no bigger than a grapefruit. The cavity where the brain sat was only about 6 centimeters wide. Some scientists believe that the spinal cord in stegosaurs might have taken on some of the brain's functions. But Kentrosaurus's most striking feature? Its fearsome array of spikes. Running along its back from head to tail were paired bony structures. Near the front, these looked like classic stegosaur plates, but farther down, along the tail, they turned into sharp, deadly spikes. And that tail was no joke. Highly mobile, made up of about 40 vertebrae, and accounting for nearly half the dinosaur's body length. Predators had to think twice before taking on a Kentrosaurus. And if that wasn't enough, each shoulder carried an extra long spike, like a knight's lance, ready to defend against an ambush. Nukensaurus, the sauropod who thought he was a turtle. About 80 million years ago, near the end of the Age of Dinosaurs, an unusual sauropod roamed the lands of what we now call Argentina and Uruguay. Nukensaurus belonged to the Saltasaurid family, part of the larger Titanosaur group. In many ways, it looked like a classic sauropod, thick, pillar-like legs, a long neck, and a powerful tail. It was named after the Neuquén River, near where its fossils were found. For a long time, fossils of Nukensaurus were thought to belong to an older species of Titanosaur, first described way back in the 19th century. But in 1992, after more discoveries, scientists finally recognized Nukensaurus as its own unique species. Nukensaurus was relatively small for a sauropod, about 7 to 9 meters long, and weighing no more than 3.5 tons. Some estimates even suggest it could grow up to 15 meters. Faced with predators, Nukensaurus had evolved a clever defense, a tough armor made of dense bony plates and sharp spikes covering its back, almost like a living tank. This natural armor would have offered vital protection against the deadly bites of the giant predators it shared its world with. Dinosaur, the last predator, or the first bird of prey. Meet Dinosaur, a fierce little dinosaur from the late Cretaceous North America. Its incomplete skeleton was discovered in New Mexico in 2008 and finally described in 2020. Even though the fossil remains were fragmentary, scientists were able to reconstruct much of its appearance and make some amazing discoveries. The name Dinobellator honors the Navajo warriors, a tribute to its deadly, predatory nature. This dinosaur wasn't huge, only about 2 meters long and weighing around 22 kilograms. Some estimates say it might have reached 3 meters and up to 40 kilograms. Dinobellator belonged to the dromaeosaurid family, the same group as the famous velociraptor. It had the classic look of a small, agile theropod, but with some key differences. Its forelimbs were especially strong and flexible, perfect for grabbing and holding struggling prey like small dinosaurs, lizards, and mammals. Another cool feature? Its tail was unusually flexible at the base, allowing it to make lightning-fast turns while sprinting after prey. And here's something we know for sure. Dinobellator was feathered. Tiny bumps on its arm bones, called quill knobs, are the same structures that anchor flight feathers in modern birds. Amargasaurus, the punk rock dinosaur. If dinosaurs had subcultures, Amargasaurus would have been the ultimate punk rocker. This bizarre sauropod roamed ancient Argentina during the early Cretaceous, about 125 to 130 million years ago. We know about Amargasaurus from a single, almost incomplete skeleton discovered in 1984 and described in 1991, though unfortunately the tail was missing. In many ways, Amargasaurus looked like a classic sauropod, walking on all fours, using its long neck to browse treetops. But its neck, oh, the neck. Running down it were 2 parallel rows of tall, bony spines, some reaching up to 60 centimeters long. Early reconstructions showed Amargasaurus sporting 2 rows of bare spikes, like a dinosaur version of a mohawk. However, recent studies from 2022 suggest those spines might have been connected by sheets of skin, creating a sail or crest along its neck and back. If that's true, then Amargasaurus wasn't just a punk rocker. It had a stunning neck sail to show off during mating displays or territorial fights. Amargasaurus could reach up to 13 meters in length and weigh around 4 tons. Each foot had 5 toes, and at least one toe bore a strong claw, possibly used for defense or to reach higher branches. Yubarahara, the peacock of the dinosaur world. Say hello to Yubarahara, a tiny dinosaur that looked like a cross between a rooster and a fashion model. This small theropod belonged to the Compsognathid family. It was described in 2020 after an amazingly well-preserved fossil was found in early Cretaceous rocks in Brazil. Today, the fossil's removal from Brazil is the subject of an international dispute, but the discovery itself is truly remarkable. Yubarahara was about 1 meter long, with half that length made up by its long, slender tail. Its body was covered with hair-like protofeathers, giving it a fuzzy, almost mammal-like appearance. Along its back, these filaments formed a shaggy, dramatic mane up to 10 centimeters long. But the real showstoppers were the ribbon-like structures growing from its shoulders. Each ribbon stretched about 15 centimeters outward, probably made of keratin, the same material as our hair and nails. These flamboyant ribbons gave Yubarahara its name, which means Lord of the Spear, in the language of the local indigenous tribe. Similar structures can be seen today in birds like the standard-wing bird of paradise, only much smaller compared to Yubarahara's impressive displays. Kehong, the rainbow flyer of Jurassic China. Imagine a tiny dinosaur, about the size of a crow, covered in shimmering, iridescent feathers. That's Kehong, whose fossil was discovered by a farmer in China in 2014 and officially described in 2018. Kehong was a small predatory theropod that likely hunted insects, lizards, and tiny mammals. It lived mostly in trees and may have been able to glide from branch to branch, though it probably couldn't truly fly. Its skull resembled that of other small raptors, but with one dramatic difference: a prominent bony crest running between its eyes. What excited scientists the most, though, was Kehong's dazzling feather coloration. Using microscopic analysis, researchers found that Kehong's feathers contained structures similar to those that give hummingbirds their brilliant colors today. Most of its body was dark, resembling the glossy black of modern-day crows or penguins, but its head and neck were likely splashed with bright, metallic hues. Imagine a shimmering, rainbow-necked dinosaur gliding through Jurassic forests. Simply magical. Gigantoraptor, the giant with the beak of a turtle. In 2005, in the deserts of Inner Mongolia, scientists found something amazing: fragments of bone and a lower jaw. From what turned out to be the biggest oviraptor ever discovered. Meet Gigantoraptor, described officially in 2007. The dinosaur found was only 11 years old and still not fully grown. Even so, it already measured about 8 meters long and weighed over 2 tons. Its legs were powerful, its body built for speed. Gigantoraptor could probably outrun many predators. Its lower jaw was unusual too, wide, toothless, and curved inward, almost like a turtle's beak. Scientists believe Gigantoraptor used its huge beak to munch on plants, although it might have also eaten small animals when it got the chance. There's no direct fossil evidence that Gigantoraptor had feathers, but given that smaller oviraptors did, it's very likely it had at least some feathery covering, possibly to help insulate its eggs while nesting, or maybe just show off. Nature's arm race began long before life left the water for the land. That exit was partly driven by the need for animals to escape predators. At the beginning of the dinosaur era, some animals were still growing teeth and claws, while others were developing tough armor. One of these armadillos is the subject of our new issue. As you may have guessed, today we're going to tell you about the evolution of ankylosaurs. We remind you that by subscribing to our channel, you could be the first to know when new videos are released, so we advise you to do it right away. We also encourage our viewers to be more active in expressing their opinions on the work of the channel's creators through comments and likes. The species of shelled dinosaur that gave its name to the entire family was discovered in 1908 by the famous American explorer, Barnum Brown. Ankylosaurus turned out to be one of the last non-bird dinosaurs to appear on Earth. It lived at the very end of the Cretaceous period in western North America. It's currently the only species of its kind. The entire family consists of 19 separate genera and a subfamily that includes 7 other genera of Ankylosauridae. Most interestingly, scientists still do not have the complete skeleton of Ankylosaurus. Its appearance is reconstructed from the available scattered specimens and similar bones of related species. This lizard is currently considered to be the largest in its family. Its body length is estimated at between 6 and 10 meters, and its mass at almost 8 tons. The appearance of Ankylosaurus's head is reconstructed by 3 well-preserved skulls, and all these skulls are slightly different from each other. Scientists explain this by the individual characteristics of each one. They also have too little information about how these animals changed as they grew up. The head of Ankylosaurus is triangular, the back is wider and flatter, while the front ends in a beak formed by the premaxillary bones. Round or slightly oval eyes, due to the shape of the head, are not strictly lateral as in other herbivores. It is thought that in earlier ankylosaurids, the ridges were not of the same construction as the horns. This is exactly how they're arranged in the related Pinacosaurus and Euplocephalus. From below, the eyes of ankylosaurs were protected by zygomatic horns that pointed backwards and downwards. Scientists believe they were formed from osteoderms, ossified plates of skin fused to the bones of the skull. In general, the entire head of the Ankylosaurus was covered with so-called cranial plates, a complex bone structure that formed as the animal matured. It was found that young ankylosaurs had gaps between the plates of the head armor, With age, this structure became an almost monolithic defense. The bone scales on the head of different ankylosaurs could differ in shape and size, but they were always arranged in the same way. It is clear that this dinosaur moved on 4 limbs and that its hind legs were longer than the front ones. It's thought that the hind legs of the Ankylosaurus had 3 toes, as in other more evolved members of the family. The cervical vertebrae of adult Ankylosaurus have well-developed entheses, tendon attachment points. This indicates the presence of a strong neck designed to support a large dinosaur head. The dorsal vertebrae were short and close together. This suggests poor mobility of the spine, especially in the vertical plane. It's thought that the base of the ankylosaur's tail was very flexible, allowing it to bend at a large angle relative to the body. This mechanism was used by ankylosaurids for defense against predators. A bony club at the end of the tail was used for this purpose. Ankylosaurids' closest relatives, the dinosaurs of the Nodosauridae family, did not have these weapons. They only had strong armor for protection. There are no precise data on the position of the osteoderms on the back and neck of ankylosaurs because they're not found in articulated form in any of the available specimens. All variants of their arrangement are based on data obtained from the analysis of the remains of closely related species. Their length ranges from 1 to 35.5 centimeters. They're thin and convex on the underside. The back was probably protected by several rows of large plates. Their size decreased as they approached the pelvis. The lateral osteoderms were more square in shape. The neck of Ankylosaurus was protected by 2 semicircles of strong plates. The only known tail mace is 60 centimeters long, 49 centimeters wide, and 19 centimeters high. This formidable weapon had a semicircular shape and consisted of 2 osteoderms on either side of the tail. The tails of ankylosaurids such as Euplocephalus and Scolosaurus had a similar structure. They were narrower in Odontosaurus and more elongated in Diapolosaurus. In general, Euplocephals, Anodontosaurs, and Scolosaurs are the closest relatives of ankylosaurs, and they all belong to 3 different holotypes of the same species of ankylosaurids. These animals lived about 75 to 76 million years ago in what is now the United States and Canada. They were up to 6 meters long and could weigh up to 2 tons. The largest Euplocephalus skull found is 478 millimeters wide and 411 millimeters long. One of the Scolosaurs found in the Canadian province of Alberta is a truly unique specimen. It's better preserved than any other known ankylosaur. Most importantly, this specimen's skin is intact. It's allowed scientists to reconstruct the presumed location of many osteoderms on the body of ankylosaurids. Currently, researchers have the remains of 40 individuals belonging to this species of ankylosaur. Most of them are connected in Alberta and Montana in the United States. The exact time and place of the appearance of the first ankylosaur is difficult to establish. It's known that the evolutionary branches of ankylosaurs and their closest relatives, the stegosaurs, diverged in the middle of the Jurassic period. Later, the armored herbivorous lizards split into ankylosaurids and nodosaurids. Ankylosaurids are essentially the more advanced of these 2 branches. Until recently, the earliest ankylosaur was thought to be an ankylosaurid genus such as Minmi. It was discovered in Australia in 1964. It lived there around 113 to 119 million years ago. At the beginning of the Cretaceous period, in many ways, this small lizard can be seen as a transitional form between ankylosaurs and nodosaurs. Different sources place it in one family or the other. It was named Minmi in honor of the pass where it was found. This baby weighed around 300 kilos and grew to a maximum of 3 meters in length. But remember that Australia was already isolated from the rest of the world at the beginning of the Cretaceous period, and perhaps the evolution of ankylosaurs just went its own way here. Externally, Minmi was similar to other ankylosaurs, but lacked a tail mace. In addition, its bony armor also protected its abdomen, and it had additional elongated spines on the sides of its thighs. These are thought to have served as a defense against a rear attack. It's likely that ankylosaurids, in their classic form, originated in Asia, where many members of the family have been found. Their remains date from the end of the Jurassic to the beginning of the Cretaceous. But recently, in 2021, the earliest ankylosaur to date was found in Morocco. It was named Spicamella or Spicamellis, which means collar with spikes. The find is estimated to be around 168 million years old. The title of the earliest stegosaur is being challenged by a find from Scotland that is a few million years older. But this dinosaur does not even have a name. What's more, scientists have not yet decided whether it was a stegosaurus or an ankylosaurus. Most of the known Europod dinosaurs, which include ankylosaurs and stegosaurs, lived on the Eurasian continent, which include today's northern continents. But Europods from Gondwana to Spicamella were virtually unknown to science. Previously, only Adrodiclet, a primitive Jurassic stegosaur, had been found on the continents of the southern hemisphere. On the one hand, Spicamella is a basal, for example, primitive ankylosaur, but on the other hand, it has a feature that is not characteristic of any armored dinosaur. Yes, and in general, there's no other vertebrae in nature that doesn't have its external armor attached directly to the bones of the skeleton. That's right, the osteoderms in Spicamellis were not built into the skin and soft tissues, they grew directly out of the bones. We don't know exactly how big this ankylosaur was. From the available fossils, scientists can only assume that its adult length was probably no more than 3 meters. At least 2 of Spicamellis' relatives lived on Earth at about the same time as Spicamellis. About 160 to 165 million years ago, the notosaurid Sarcolestes lived in the area that is now England. Its jaws are more similar to those of other notosaurs, but the structure of the teeth and the presence of a shell plate fused to the jawbone are more characteristic of ankylosaurs. Scientists believe it was a massive animal, not exceeding 3 meters in length. Sarcolestes did not have a tail claw. And in the territory of China, almost at the same time as Spicamellis, there lived a real ankylosaur called Tyrannosaurus, which means lizard of the heavenly pond. It's worth noting that the original name of this genus sounded like Jurassic. This name was given in honor of Steven Spielberg's film Jurassic Park, as it was the famous director who funded the research into Chinese dinosaurs. There were even attempts to create the species name Jurassic from the surnames of the main stars of the first part of the film franchise, but as time went on, scientists decided to abandon this idea. It's quite difficult to get a detailed description of the appearance and size of Tyrannosaurus. Currently, scientists have about 20 vertebrae, fragments of limbs, and scattered bone plates. It seems that about 110 million years ago, the evolution of North American and Asian ankylosaurs proceeded in much the same way. Since then, larger and larger varieties of these herbivorous lizards have appeared in both regions. They already have the appearance of classic ankylosaurids, with strong armor and a bone club at the end of the tail. Modeling the operation of such a weapon showed that an ankylosaur's tail could move at an angle of 100 degrees. A single blow from the club could have broken the limb of a fairly large predator. Moreover, as the dinosaur matured, the club became not only larger, but also much stronger. However, scientists have not yet been able to determine whether this weapon was used against predators or just for rivalry within the ankylosaur community. Late Asian ankylosaur species include Bicycipelta and Pinacosaurus. Bicycipelta is the first member of the family to be discovered in Uzbekistan. This 65 to 82 million-year-old ankylosaur was described in 2004. Its estimated length is 7 meters, and its body weight is 4 tons. Modeling of the Bicycipelta skull using the latest research methods showed that these lizards had excellent hearing and a good sense of smell. Scientists also discovered a unique brain cooling mechanism that these dinosaurs had developed during evolution. Pinacosaurs lived in Mongolia and China. They weighed up to 2 tons and grew up to 5 meters long. The age of the specimens found is between 75 to 80 million years. The skull length of an adult Panocosaurus was about 30 centimeters. The lizard had 5 fingers on each foot. The back of Panocosaurus was protected by oval plates. Among the armored dinosaurs from North America, it's impossible not to mention a lizard such as Borealopelta. Although it belongs to the Nodosaurids, its discovery can shed light on an important part of the description of ankylosaurs. This dinosaur was found in the Canadian province of Alberta. After death, it probably ended up at the bottom of a reservoir and was therefore better preserved than many other specimens. The specimen was described in 2017. In addition to the presence of unique long spines on the shoulders, scientists have been able to reconstruct another important detail of the lizard's appearance: its coloration during life. Studies have shown that Borealopelta's skin color was reddish-brown. In general, it was a fairly large nodosaur, up to 5 meters long and weighing almost 1.5 tons. It's almost impossible to talk about all the ankylosaurs that scientists have described in one video. During the dinosaur era, dozens of genera and species of these unique lizards lived in Asia, Europe, and the Americas. Overall, it's clear that as they evolved, they grew larger and acquired more complex armor. Hopefully, over time, science will be able to shed light on the different characteristics of this whole group of amazing dinosaurs.
What if Tyrannosaurus rex was an overgrown chicken? Since the discovery of the first remains of Tyrannosaurus rex more than 100 years ago, and until recently, it appeared to most people as a huge, toothy, bipedal lizard. In many ways, this image was created by modern mass culture. But what was the disappointment of scientists who came to the conclusion that the most terrible predator of the age of dinosaurs, as a result, degenerated into an ordinary domestic chicken? In this video, we will talk about the discovery of family relationships between dinosaurs and modern birds, and also find out how close relatives of domestic chickens and theropods are that of the Tyrannosaurid family. Viewers who subscribe to our channel will be the first to know about the appearance of new videos about the life of dinosaurs and other living organisms that inhabited our Earth at different times. Our subscribers can express their opinion about the work of the creators of the channel in the comments and support us with likes. The first finds of Tyrannosaurus rex bones were made by the American paleontologist Barnum Brown in 1902. These were scattered bones, from which scientists were able to collect only the hind limbs. But in 1908, a skeleton fell into the hands of researchers, almost 50% preserved. The main thing in this find was a well-preserved skull. Impressed by its jaws and teeth, scientists named this giant the Tyrant King of Lizards. According to modern estimates, Tyrannosaurus could reach 12 to 13 meters in length and have a height of up to 4 meters. They lived on the territory of the modern USA and Canada, and also, possibly, lived in the Asian part of Russia and neighboring states. The T-Rex weighed about 6 to 9 tons. Such dimensions combined with huge claws and teeth, powerful hind limbs, and a large head and strong neck allowed scientists to put this monster at the top of the food pyramid of the late Cretaceous period. For many years, T-Rex became the personification of the greatness and bloodthirstiness of dinosaurs. But after the appearance of data of the presence of feather cover in dinosaurs, many looked at this monster at a slightly different angle. Although there is no reliable data on the presence of feathers on the Tyrannosaurus itself, many facts have appeared that have proved its undoubted relationship with modern chickens. One of the most important finds proving the origin of birds from dinosaurs is without a doubt such a mysterious creature as Archaeopteryx. It has features that are characteristic of both types of creatures and is considered a transitional form between them. In the modern classification, the Archaeopteryx family belongs to the class birds, but this creature differs very much from modern representatives of this class. Archaeopteryx lived on the territory of the European continent about 150 million years ago in the Jurassic period. Its weight was about 1 kilogram, and the dimensions could reach 50 to 55 centimeters. Scientists suggest he was a predator and may have been able to fly. In this, he was helped by almost full-fledged wings covered with feathers. But at the same time, his jaws were equipped with sharp teeth and did not at all resemble a beak. He also possessed such signs of a dinosaur as claws on the forelimb and a bony tail. Currently, science knows of 12 samples of the fossilized remains of this creature. Their study made it possible to draw conclusions about the presence of feathers in Archaeopteryx, not only in the wings, the tip of the tail, and metatarsal bones, but also on the legs, neck, and other parts of the body. At the time of the discovery of the first remains of Archaeopteryx, Darwin's theory was not yet recognized by most scientists as correct, and Archaeopteryx was classified as a bird. The British scientist Thomas Henry Huxley tried to substantiate the version of the origin of birds from dinosaurs, but it was not accepted by official science. Therefore, the T-Rex remained in the public mind for a long time as a huge carnivorous lizard, and science did not connect it with modern birds in any way. The next step in recognizing the relationship of dinosaurs with birds happened almost in the 60s of the 20th century. During excavations in southern Montana, paleontologist John Ostrom discovered a dinosaur species previously unknown to science called Deinonychus, which means terrible claw. Brown was first to describe the remains of this dinosaur more than 50 years ago, but then he mistook them for the bones of a completely different dinosaur. Ostrom compared these specimens with new finds and classified them as a new species from the Tyrannosaurid family. Deinonychus, like the T-Rex, was a predator, but at a much smaller size. With a growth of just over 1 meter and a body length of about 3 meters, Deinonychus weighed no more than 70 kilograms. But the study of the preserved bones of this relative of the Tyrannosaurus allowed us to assume that he had not only the presence of a feather cover, but also for the first time to talk about the warm bloodedness of dinosaurs. In addition, Deinonychus had a fairly large brain. These discoveries have completely changed scientists' understanding of the appearance and habits of theropods in particular, and dinosaurs in general. In light of the discovery of new facts, John Ostrom re-examined the remains of Archaeopteryx and found a large number of similarities with the newly discovered species of dinosaurs. One of the most important evidence of the relationship was the same structure of the wrist. The number and shape of Deinonychus's wrist bones allowed it to fold its forelimbs in the same way as birds do. Also, along the spine of the Deinonychus were found openings characteristic of the respiratory system of birds. These are the air sacs. After the discovery in the 90s of the last century of the almost complete skeleton of a Tyrannosaurus rex, which received its name, Sue, the similarity of the structure and shape of its bones with the bird's skeleton became undeniable. But the presence of feathers was not confirmed even then. There are several opinions regarding the plumage of the T-Rex. Since he was much larger than his feathered relatives, he probably did not need additional insulation. A similar phenomenon can be observed in modern mammals. While some small animals almost always have fur, the largest creatures, like elephants and rhinos, remain naked. So in the course of evolution, they solved their problems with thermoregulation. Maybe a feathered Tyrannosaurus simply could not survive in those conditions, suffering from regular heat strokes. There is also an opinion that Tyrannosaurs were covered with a layer of protofeathers similar to the down of modern birds. Another evidence of the origin of birds from theropods, scientists call similar behavior in terms of caring for offspring. It has already been proven that many small bipedal lizard dinosaurs, such as Oviraptor, incubated their eggs by warming them with the warmth of their bodies. Here, plumage could also play a role. In addition, the shape of the found eggs of many theropods is very similar to birds. Of course, the oblong shape of the eggs is more convenient for their preservation. But other egg-laying creatures in the course of evolution did not come to just such a form. Such a giant as a Tyrannosaurus, of course, was hardly engaged in incubation of eggs. For this procedure, his body certainly was not adapted, despite all the similarities with birds. It is believed that they could build special nests, creating an optimal microclimate in them, as another relative of the birds, crocodiles, does. And in 2001, paleontologist Mary Scheitzer examined a piece of Tyrannosaurus rex femur under a microscope and found a truly amazing thing. Inside the bone, remains of soft tissues are preserved, similar to substances that are formed in modern birds only in the process of gestation. Such bones are called midullar. Their presence in the T-Rex was another fact that confirmed the hypothesis of Thomas Huxley, expressed in the second half of the 19th century. Birds are descendants of theropods. Of course, to say that our domestic chickens are the same as tyrannosaurs that terrified the entire planet many millions of years ago is fundamentally wrong. But modern science has a sufficient number of facts that speak of their undoubted relationship. We can only assume that if dinosaurs had not died out 66 million years ago, then in the course of evolution, the descendants of the formidable Tyrannosaurus rex would now look like fluffy chickens, maybe only a little larger. We all imagine Tyrannosaurus rex and its closest relatives as giant theropods with huge teeth. And the babies of these dinosaurs are usually depicted as a smaller copy of their parent. And if the general public has at least some idea about the diet of adult tyrannosaurids, the feeding method of young animals remains a mystery even to scientists. But science does not stand still. Not long ago, the results of a study of the remains of a young Gorgosaurus found in Canada 14 years ago were published. They allowed scientists to draw certain conclusions about the process of development of the most dangerous predators of the era of the dinosaurs. Subscribe to our channel, then you'll be the first to know when new videos about the life of the age of dinosaurs will be published. Also from our issues, you can learn many interesting details about the development of life on Earth in general. And thanks to your likes and comments, more and more viewers are watching our videos. Tyrannosaurids include a large number of species that lived in Eurasia and North America at the end of the Cretaceous period. It is believed that they crossed to the American continent via a land bridge across the Bering Strait. This is evidenced by fossil finds in what is now Japan. These were large theropods with powerful hind limbs and practically vestigial forelimbs. Their main weapons were huge jaws, supported by strong muscles and a short neck. The largest of them is considered to be the species that gave its name to the entire family. Scientists estimate that an adult Tyrannosaurus could weigh up to 18 tons, but earlier representatives of the family were less massive. Scientists cannot fully determine the feeding method of the largest predator in the history of the planet. Most studies suggest that tyrannosaurs were active hunters. Most likely, they used ambush tactics. They made a rapid dash from cover, grabbing the victim with their teeth or ramming it. The impact of such a massive carcass could not only knock one down, but also cause serious damage, even breaking limbs. Thanks to its enormous bite force and the strong short neck, the T-Rex could lift its captured prey and shake it. Very few animals from the age of the dinosaurs could resist this killing machine. But this image of the T-Rex among the general public is largely formed by various artistic and documentary works. In fact, as seen in films like Jurassic Park, the Tyrannosaurus rex is an advanced adult. Scientists find bite marks from large theropods on the remains of a wide variety of herbivorous dinosaurs. Quite often, such markings are found on the back parts of the skeletons of various ceratopsians. There is also evidence of tyrannosaurids attacking each other. This may indicate either a fight for females, territory or prey, or cannibalism. The fact that tyrannosaurs and their closest relatives did not disdain to eat their relatives is evidenced by bite marks on the limbs. Such injuries are not typical for dinosaurs fighting among themselves. Several scientifically proven facts support the idea that tyrannosaurs were active predators. Tyrannosaurids had binocular vision. The eye sockets on the discovered turtles are located in such a way that they allow the animal to look forward. This also makes it possible to better estimate the distance to various objects. This skill is undoubtedly important for predators, but among herbivores, there are many examples of a similar arrangement of eyes. At the same time, there is a well-founded opinion that the Tyrannosaur's vision was quite good. Some researchers claim that he could see no worse than modern birds of prey. We have already mentioned that Tyrannosaurus bite marks on the remains of various large herbivores are quite common. There are finds of Triceratops skeletons with damaged collars, and many herbivores had quite powerful armor on their neck and back. This suggests that protection from attacks on these areas was a necessity. These dinosaurs regularly encountered large predators attacking them from above or from behind. Another argument of supporters of the theory that tyrannosaurs obtain their food by hunting is the structure of their teeth. The sharp, curved back teeth, up to 30 centimeters long, had serrated edges. They were ideally suited for capturing prey and inflicting painful wounds. Large jaws and powerful chewing muscles provided a bite force comparable to that of modern crocodiles. Scientists are still arguing about the maximum running speed of tyrannosaurs. Some say that with such a mass, they could not run fast. Others believe that the structure of its legs allowed him to develop good speed. It is unlikely that a T-Rex could chase a car for a long time, as shown in some feature films, but it would be very difficult for a person to escape from him. And the dinosaurs that tyrannosaurids could hunt were apparently not excellent runners either. Proponents of the theory that tyrannosaurs moved rather slowly believe that the basis of the diet of these animals was carrion. Also, given their size and weapons, they could take prey from more successful hunters. Also, a good sense of smell of the T-Rex and its relatives can speak in favor of eating the carcasses of dead animals. Most researchers agree that tyrannosaurids mainly obtain their food by hunting. But at the same time, they did not disdain either dead animals or their relatives. But all these arguments are valid only for adults, and they became like this only in the last 10 to 15 years of their lives. Young tyrannosaurids were not as large and deadly. Scientists find fragments of their skeletons much less often. After all, the smaller the object, the faster they collapse over time. Therefore, scientists do not know very much about the habits and feeding habits of young representatives of this family. The discovery that we talked about at the beginning of this issue has become very important for the entire paleontology. Scientists examined the remains of a young Gorgosaurus that died at the age of 5 to 7 years, approximately 75 to 77 million years ago. It was no longer quite a cub, but not yet a teenager. The maturation of the Gorgosaurs began between 10 and 14 years and lasted, according to various estimates, up to 6 years. During these years, they grew as quickly as possible, gaining from 600 to 1,000 kilograms of weight annually. These tyrannosaurids lived in Canada towards the end of the Cretaceous period. They were the closest relatives of Albertosaurus, smaller representatives of the family. Their body length reached 9 meters and height at 3 meters. The maximum weight of an adult Gorgosaurus did not exceed 2.5 tons. The found specimen was about 4 meters long and weighed a little more than 300 kilograms. Scientists have discovered skeletons of young representatives of this species before. Researchers were very surprised by the striking difference between adolescents and adult animals. It was also not entirely clear how such a rapid weight gain and transformation into adult predator occurred. One of the most likely explanations for this phenomenon was a change in diet, but scientists have not yet had material evidence of this theory. Young representatives of the largest predators simply had to occupy a different ecological niche. An adult T-Rex, like any dominant predator, had to feed in a certain territory and would hardly tolerate competitors. If the young animals ate the same herbivores, then their older comrades or relatives would simply destroy or drive them out of their land. Quite a lot is known about the diet of an adult tyrannosaurid. Judging by the marks on the bones and the analysis of the remaining coprolites, they feed on the largest herbivores. Such prey was simply too tough for individuals in the literal sense of the word. Their teeth had a slightly different structure, and their jaws were not so massive. They also had different body proportions and were slightly different anatomically from adults. In the process of cleaning the fossilized remains of a young Gorgosaurus, it turned out, at the time of death, undigested bones of another species remained in its stomach. About a week before its death, this dinosaur ate a very heavy meal. His prey was 2 small dinosaurs related to oviraptors. They too were not fully adult individuals and did not exceed the size of a modern turkey. It is believed that they were no more than 1 year old at the time of death. It is noteworthy that Gorgosaurus only ate the lower limbs of both of its victims. That is, he had the opportunity to choose the most fleshy and tasty parts of the body. It is also interesting that even though most of the bones were missing, these partially digested remains were important for the study of this species of oviraptor. Oddly enough, they are the best preserved fossils associated with these dinosaurs. When it became clear that there was something else under the ribs of the Gorgosaurus, scientists began to clean the fossilized bones from the rock from the backside. This was done so as to not damage the contents of the young predator's stomach. As a result, it was possible to preserve not only the skeleton of the Gorgosaurus, but also the remains of its meal. This find confirmed scientists' assumptions about the differences in the diet of young and adult tyrannosaurs. Cubs and teenagers ate smaller dinosaurs and the young of other species. They had to earn their own food. This discovery shed light not only on the feeding habits of large theropods. Scientists have also become more clear about the characteristics of parental behavior and relationships between dinosaurs of different ages. It is unlikely that mom and dad tyrannosaurs caught small dinosaurs for their children or shared the prey with them. They themselves had to make considerable efforts to provide for the needs of their huge organisms.
Imagine stepping outside on a cool morning. Fog drifts low across the ground, damp grass brushing your shoes. Suddenly, the stillness breaks. A deep, thunderous boom echoes from somewhere beyond the tree line. The earth trembles under your feet. And then, movement. A shadow rises above the mist, massive, scaled, alive. Rows of teeth, longer than your hand, glint in the pale light. A tail like a wrecking ball swings once, twice, knocking down saplings like matchsticks. A dinosaur. Not in a museum, not in a movie, right here, right now. What if the asteroid that wiped them out 66 million years ago had missed? Would humans have learned to survive among predators bigger than buses and faster than horses? Would our cities echo with the footsteps of living thunder lizards, or would we have been wiped out before we ever invented fire? In today's episode, we're diving into the science behind one of humanity's most thrilling questions. Could humans and dinosaurs ever have shared the Earth? And what would our world look like if they still ruled today? Science fiction writers, and later Hollywood screenwriters, have imagined the coexistence of humans and dinosaurs in various ways. Arthur Conan Doyle, in his novel The Lost World, suggested that dinosaurs still live on an isolated plateau hidden in the South American jungles. Meanwhile, Harry Harrison, in his Eden series, created a model of the world where dinosaurs evolved into intelligent, humanoid beings, while humans only developed into a primitive society. These are all products of the imagination of science fiction writers. However, in reality, there are still many people today who believe that humans and dinosaurs lived at the same time. This is supported by a recent survey conducted in the United States. Only 25% of respondents are certain that this is not true. 27% believe it might be possible, and another 14% are convinced that our ancestors saw living dinosaurs. For the most part, these misconceptions stem from religious beliefs. The religious philosophical movement that stands in complete opposition to the theory of evolution is called creationism. In short, it encompasses all theories claiming that the earth and all living things were created by God almost instantaneously, and that this happened between 6,000 and 10,000 years ago. According to proponents of this theory, dinosaurs went extinct as a result of a global flood or some other cataclysm. Another reason for such beliefs is certain scientific discoveries that are often misinterpreted by the general public. For example, in Brazil, dinosaur footprints have been found alongside traces of ancient humans. Creationists or conspiracy theorists immediately try to use such findings as direct proof of their claims. However, in reality, the age of the footprints and drawings is vastly different. Scientists estimate that the dinosaur footprints are about 140 million years old, while the artwork created by our distant ancestors appeared near them only 3,000 to 9,000 years ago. Some scientists suggest that ancient humans incorporated discovered dinosaur footprints and bones into their beliefs and mythology. This is why drawings appeared next to footprints in Brazil. After all, a massive footprint couldn't be carried to a sacred site, so a cultic place had to be established right next to the footprint. However, in this case, it's hard to say whether the markings left by humans were mystical symbols. In North America, Native Americans clearly depicted figures of praying people next to the footprint of a bipedal theropod dinosaur. Early Europeans mistook such footprints for the tracks of a raven sent by Noah to find dry land. This confusion arose because theropod footprints closely resemble those of bird feet. In ancient China, they were even thought to be the tracks of the phoenix, believed to bless the land. Perhaps the people of South America who left mysterious signs next to a dinosaur footprint thought something similar. Some scientists propose that these could be solar symbols related to the sun. However, we will likely never know what our ancestors were thinking when they left these marks next to a massive footprint. What we can say with certainty is that the dinosaur footprint and the petroglyphs beside it were created at different times. The footprint was left in wet clay, while the drawings were carved into hardened rock millions of years later. Occasionally, even in scientific circles, there are speculations that some reptiles survived the mass extinction at the boundary of the Cretaceous and Paleogene periods. These survivors are thought to have inspired dragon myths and legends in nearly every culture worldwide. We've discussed this possibility in our videos before. However, modern science provides a clear answer. This is simply impossible. Yes, some living organisms that existed alongside dinosaurs have survived to the present day. Turtles, crocodiles, and sharks were witnesses to the dinosaur era. Of course, over the intervening time, they have changed significantly. However, no living fossil larger than a frog have been identified by science in the last 100 to 150 years. It's possible that deep in the oceans there are worms or microorganisms that look the same as they did during the reign of the dinosaurs. But the likelihood that ancient Chinese people saw a petrosaur soaring in the sky and mistook it for a dragon is vanishingly small and lacks any evidence. Neither archaeology nor the analysis of written or visual sources supports such claims. Of course, descriptions of mythological creatures like Garuda could be mistaken for accounts of dinosaurs. By the same logic, these could also be interpreted as descriptions of spaceships. Some people find similar evidence in the Bible or other sacred texts. But until these speculations are backed by more scientific methods, we will consider the possibility of humans encountering dinosaurs as merely the product of science fiction writers' imaginations. There is a theory that findings like the bones of extinct animals or dinosaur footprints were simply integrated into the existing mythologies of various cultures. Stories about dragons, giants, and other monsters existed independently of living dinosaurs in nature. The discovery of giant bones, teeth, and footprints only reinforced these myths. It's worth mentioning that, once again, technically, dinosaurs are still living among us. Birds are officially classified as theropods, a group of Saurischian dinosaurs. They are the closest relatives of oviraptors and dromaeosaurs. In other words, the ancestors of modern birds were dinosaurs that survived extinction and evolved into domestic chickens, city pigeons, beautiful hummingbirds, predatory eagles and hawks, and many other species. So, the next time you're feeding pigeons in the park or cooking chicken legs for dinner, remember that humans have managed to tame even dinosaurs. We eat their meat, keep them in cages, hunt them, and at the same time strive to preserve these very real dinosaurs in the wild. Despite all the evidence against the simultaneous existence of humans and dinosaurs, this topic is regularly revisited in both science and fiction. There are even several theories about what such a society might look like. We'll leave the musings of writers and screenwriters for the next episode. For now, let's explore the scientific perspective on this issue. First, we need to make a few caveats and assumptions. In constructing our model of evolution, we won't consider the hypothesis that the extinction of dinosaurs was influenced by the rise of mammals and the appearance of flowering plants. After all, we need not only for dinosaurs to survive, but also for Mesozoic mammals to evolve into modern humans. Imagining what the modern world would be like without flowering plants is even more challenging. So, to understand how humans might coexist with dinosaurs, let's simply assume that 66 million years ago, a massive asteroid missed our planet and volcanic activity didn't cause significant climate changes. Scientists still haven't determined whether all dinosaurs were warm-blooded. However, it seems that only the ancestors of modern birds had this trait. If so, cold regions like Siberia or Alaska would have been inaccessible to most dinosaurs. In these areas, mammals would have reigned supreme. In warmer climates, particularly on vast grassy plains, mammals would have had little chance to thrive. African savannas, North American prairies, and Central Asian steppes would be populated by diverse horned, armored, and duck-billed dinosaurs. It's unlikely that horses, bison, antelopes, or large hoofed animals would have emerged in such conditions. like at the dawn of their evolution, they would remain small forest creatures. Large predators like lions and bears would also likely struggle to compete. Their ecological niches would be occupied by bipedal theropods. However, in the smaller weight class, mammals would likely prevail. Small dinosaurs would lose the survival battle to more advanced and adaptable competitors. Meanwhile, large dinosaurs could grow even larger. We must also remember that, along with dinosaurs, many species of birds and early placental mammals went extinct. If the Cretaceous-Paleogene extinction hadn't occurred, these species would have continued their evolutionary paths. It's likely that we would see a great number of relict animals, similar to the egg-laying mammals found in Australia. Another possibility is the parallel development of dinosaur and mammal faunas on different continents after their separation. In reality, this happened with Australia. Due to its isolation from the rest of the world, its fauna evolved in a unique way. There's even a chance that two separate civilizations could have emerged independently: modern humans and intelligent dinosaur descendants. This assumption forms the basis of Harry Harrison's Eden series, mentioned earlier. This famous science fiction writer proposed that dinosaurs, having appeared earlier, would reach a higher technological level, while humans would only master Stone Age technologies. However, at the time of writing, the author was unaware of the warm-blooded nature of some dinosaurs. Thus, cold climates became humanity's salvation from complete destruction. In Harrison's world, dinosaur descendants became masters of biotechnology. Their weapons were snakes that fired venomous projectiles, and they sailed the oceans on ships grown from marine reptiles like plesiosaurs. Yet, humans successfully resisted their more advanced rivals thanks to their intelligence and adaptability. How do scientists view the possibility of an intelligent dinosaur civilization? We all know that real dinosaurs weren't particularly intelligent. The size of their brains relative to their body mass was tiny. However, their evolution didn't stand still. By the end of the dinosaur era, some species were already warm-blooded. Others had transitioned to sexual reproduction. The most advanced predatory dinosaurs had multiple types of teeth designed for different tasks. There's even a well-founded theory that diverse teeth indicate high intelligence in animals. Therefore, we cannot entirely rule out the possibility of intelligent dinosaurs emerging if they hadn't gone extinct 66 million years ago. Some scientists suggest that they could have become more humanoid in appearance, as the most advanced dinosaurs had already mastered bipedal walking. They also had forelimbs with hands, which humans inherited from a shared ancestor through many generations. It's possible that the hands of these dinosaur humans would be more developed and stronger than ours. Their skin would likely be thicker and scalier, and they might periodically shed it, not just a result of a sunburn. If our ancestors were dinosaurs, we would likely be more sensitive to temperature changes and have sharper vision and sense of smell. These ancestors wouldn't be the largest dinosaurs, but rather the smartest ones. Considering that even these could stand between 5 and 15 feet tall, the average height of modern humans might be much greater. Another question is how such a society of dinosaur humans would develop. Since they weren't particularly large or strong, claws and teeth would eventually be replaced by sticks and stones, followed by more advanced weapons and tools. However, this process would likely be slower than it was for primates. The mastery of fire would also happen much later than it did for our real ancestors. The subsequent formation of groups, clans, tribes, and nations would naturally follow, as cooperation is essential for surviving large predators and other dangers. Society would likely develop along a similar path to ours. We can't say whether such beings would be smarter or more advanced than us, but their medicine, science, economy, and other societal institutions would undoubtedly develop differently from our own. Another important topic in these discussions is whether humans would have had a chance to emerge and develop if dinosaurs hadn't gone extinct. Early primates did exist during the time of the last dinosaurs, but they bore little resemblance to humans or modern apes. They were closer to rodents. On the other hand, the climactic changes that forced our ancestors to descend from trees and adopt bipedal walking could have promoted these primates to do the same. Our real ancestors survived in the presence of large predators like lions and leopards. If they had to escape from dinosaurs or raptors instead, the situation wouldn't have been drastically different. Ultimately, human evolution didn't develop solely on the extinction or survival of dinosaurs and other Mesozoic animals. It required a stroke of luck. The conditions that led to the emergence of the first humanoid creatures in Africa a few million years ago were specific. In South America, for example, ancient primates only evolved into other types of monkeys, and in North America, primates migrated at least 3 times, all unsuccessfully. As history shows, there's no room for what-ifs. Humans and dinosaurs never crossed paths on their long evolutionary journeys. The world developed along its singular path, and we can only speculate about how these two vastly different types of creatures would have coexisted if the dinosaur era hadn't ended. The creator of the Age of Dinosaurs channel thank our viewers who watch our episodes to the very end. To learn more about the lives of real dinosaurs and other prehistoric animals, check out our previous videos. They also cover the history of their discovery and study, human evolution, and modern ecological issues.